All right. So this is a force equilibrium thing that's not gonna actually be solved easily, right? So first thing I want to do is I just want to draw these components. Let's express these components. We're gonna have a couple unknowns and a couple equations here, right? So this force here is going to act along that string there, right? And it's going to have a x component and a y component, right? And if that angle is 56 degrees, then this side here is what? That's d sine 56. And this side here is d cos 56, right? And then the force along the C, what I'm going to do here is I'm going to draw the x component first and see if I can do that. The x component, the trick here is that these guys are equal but opposite, right? Okay, and then the y component is here. And so that would predict the only way that this is D, right? This is C. Okay, if these are forces, right? C is going to be a smaller force than D. It's always that the vertical one has a little bit more force. And the reasoning behind that is, well, two ways to reason this out, right? One is that it's more vertical and gravity is going to act straight down, right? Okay, so the one that's more straight up has more tension in it. The other way to look at it is that they both have the same x component, equal but opposite, right? Because the x has to add to 0. Okay, and so if you look at that, the geometry of this means that this guy's got to be longer to have the same x component because it's more steep. Okay, and then so this side is that's going to be c sine 34, and then of course this side here is going to be c cos 34, right? And then the final force it's acting on here is okay, 35 times 9.8, 9.81. Okay, so 35 times 9.81 is 343.35. All right, so let's just set up our equations here. In the x direction, we've got this guy acting in the negative direction, right? Okay, so we've got negative c cos 34, right? And then we've got positive d cos 56. And that's all there is in the x direction, right? So that adds up to 0, right? In the y direction, we've got positive y direction, right? Sine 34, positive d sine 56, right? So that's this guy here, right? These guys are in the y direction. And then, of course, we've got this guy acting down, right? So minus 343.35 equals 0, okay? So now we've got two expressions and, two unknowns, two equations, two unknowns. It's not trivial. We're going to have to either do substitution or matrices. I say let's use matrices. Okay, so to recast this in matrix form, let me just suggest that we just say, okay, let's put this on the other side, right? So that the forces up equal the forces down. In fact, you can set up equilibrium equations that way, right? Okay, and then notice we've got it set up so we've got all the C's above each other, all the D's above each other, right? So we can represent this. We know that that's the matrix CD, okay, is equal to this matrix minus cos 34 cos 56 sine 34 sine 56. Right, so you just strip off all these coefficients of C and D, stick them in there, right? And then we invert that one, right? And then multiply by 0.343.35. Okay, and there we go, right? So now we've got to do the matrix thing here, right? And, oh, there it is, all right, second matrix. All right, so you go second matrix, and I think what I want to do is edit, right? And then I'm gonna edit A is what I'm gonna do. I'm gonna call this guy A here. So there we go. So it's A, and it's gonna be 2 by 2. There we go. And then I'm gonna go negative cos for the first element. I'm typing in the first element now. Negative cos 34 and cos 56. Is it the element to the right of that? Sine 34. I'm just typing these in. Sine 56. All right, and then I'm going to quit. All right, and then I'm going to go into the matrix again. So second matrix, I'm going to edit. And now I'm going to edit B is what I'm going to do. It's kind of crazy. Okay. And B is going to be a 2 by 1. Okay. And then the top is going to be 0. 0, enter. 343.3435, right? Okay. You could just type. Okay. Now, are we ready for this? So now I'm going to quit again. Okay. And now I'm going to simply do this. I'm going to do A inverse B. Okay, so on the TI calculators, you got to go matrix, and now you're going to do names. Okay, and then you're going to choose A and invert it, and that's just raising it to the -1. I got to find, oh, here it is. This is a different calculator. Okay, and then I'm going to go B. So go second matrix names B, and see what happens. And I get, what it does is it gives me this matrix, 191.99888, et cetera, right? And then it's got 284.65. Right now, the way it works is that this one, the one that's there, is the top one, and the one that's there is the bottom one. Let's suppose you forget this. Go back to your original drawing. The one that's more vertical will be the larger, okay? So this guy here is my C, and this guy here is my D. All right, so you need to say C equals 192 newtons, 285 newtons, okay? So you need to tell me which one's which, okay? Yeah, there we go. You also need to set up your equilibrium expressions, okay? Set up your equilibrium expressions. If you do a matrix, show me what you did for the matrix. That's fine, but you know, whatever you want to do. You could do substitution. There's lots of ways to solve this, but anyway, happy hunting.